Hello everyone, my name is Liu Ziyuan. I'm from NTU SSE. Today I'm going to talk about the convolution layers. First, let's take a look at the convolutional neural networks. In this network, it takes an image as the input, and show as below, we have an input layer and a convolution layer and a subsampling layer, or we can call it pooling layers, and the repeat of these two layers, and at the last we got a fully connected multi-layer perceptron to get the class label we want. So basically it convolves several small filters on the input image. This is the job of the convolution layer, and do the subsampling, and then repeated the steps 1 and step 2 until we got the sufficiently high level features, and the MLP will give us the prediction based on the result of our features. But today we'll only focus on the convolution layer, so next we'll take a look at it. The convolution layer is used to form a richer representation of the data. Each hidden layer is composed of multiple feature maps. Each feature map is corresponding to a filter we predefined. And the filter, in this case, we can see in the yellow part, it's a 3x3 matrix. What we do for this calculation, also called the convolution operation, is to multiply the corresponding value and sum it up. So we can see that there are 4 1 and 1 multiplication, and the result of this this filter is the 4. So we just sum it up, and in some cases we will do the average after the summation, and then we can get the feature map we want. The feature map is the result of the convolution operation. And in this neural network, the weight W of a hidden layer can be represented in a 4D tensor. This is a conception we'll talk later. And following that, the feature map is obtained by the repeated application of the function across the subregions of the entire image. So in this case, we have at the start at the top left corner. After this calculation, we got the result 4, and then we move it to the right and right until to the end, and then we'll move it down a little and do the same all around again until we get the full image covered. In other words, by convolution, the input image with a linear filter, adding a Bayes term and then applying a nonlinear function, then we get the feature map we want. If we denote the case feature map and the given layer as HK and the following term defined, we can get a formula of the feature map calculation. And here is actually an example I found online. This is from my favorite YouTuber. He always talk about this beautiful conception and example. This is a example of the X recognition. He designed this network to recognize axes in the image. He defined 3 filters to get the feature of the X. It's center part and slashes and the right slashes. Then he gets a feature map in 3. Then he can use his networks to predict if it's X or if it's not an X. So convolution layer is just the critical part of the convolution neural networks. And here we are. Thank you.